Okay, now we'll see what is bounded buffer problem or producer consumer problem. Okay, this is a problem of multiprocessors synchronization. In this problem, there are two processes. One is producer process and another is consumer process. Process produces some item, files, records, etc. and places that in the buffer one by one. And the consumer process consumes or removes these items, records, files one by one from the buffer. So for example, if there is a buffer having different various slots. Suppose there are 10 slots like this, 1 to 10. So what producer will do? Producer will put the data in the slots like this, and consumer will consume the items like this. Okay. So since the size of the buffer is fixed, here the size of the buffer is fixed. That's why it is called as bounded buffer. Okay, the constraints are the size of the buffer is fixed, that is the first constraint. Second, consumer must wait if the buffer is empty. This is not natural, because if nothing is there in the buffer, consumer cannot consume anything. Okay, so consumer has to wait for a producer to keep something in the buffer. Okay. Third is producer must wait if the buffer is full. So if the buffer is all the segments, all the slots of the buffer is full, then producer cannot put extra or new thing into the buffer. So producer has to wait till the buffer becomes empty. Okay. And the last and important is either producer or consumer can access the buffer at a particular time. Okay, why it is so? Because buffer is common to producer and consumer. Okay, so important point to be remembered is both the processes cannot work simultaneously. Both are sharing buffer, so buffer will be in the critical section. Since we already know, or we have already studied that the common variables or the common resources we save where we store it in the critical section. Why? Because both the processes cannot access the shared resources, otherwise there will be a race condition. Okay, so here the buffer is common, so we are going to keep it in the critical section. So we can use semaphores here for synchronization. So there are three semaphores we are going to use here. First is S, E and F. S is equal to 1, that is initialized to 1, that we have already studied in the last video for the selection of the process, whether it's a producer or a consumer process. Then second is E equal to N. What is N? N is the size of the buffer. Okay. So initially there, how many empty slots are there? So initially producer has not put anything in the buffer. So the empty slots will be 10 in this case. Okay. So E will be equal to 10. Then F is equal to 0. So what is F? F is the number of full slots. So initially nothing is there in the buffer. So the full slots will be equal to 0. Okay. Okay, now we'll see the implementation of it. So we are familiar with this part, this here and here. Okay. So we are taking the buffer size here equal to 10, and the initialization of S is 1. E will be equal to 10 because it's empty slots initially, empty slots, and these are full slots. So now this is the producer which will produce something, and here it's a weight E. What is the value of E? E is 10. So it will go into the weight, and this 10 becomes 9. Then what is the next? Next is weight S, where S is equal to 1. So it will be 0. So it will enter the critical section, which will append the buffer, and then there is a signal S will increment the value of S from 0 to 1. Okay, and signal F. So what is the signal F? It will increment the value of F from 0 to 1. Initial value of F was 0 because the full slots were 0, but here now as soon as you in append one slot of the buffer, the one slot is full, that's why the value of F became from 0 to 1. Okay, so next time again if the producer enters here, so what is the value of E now? So E will become 9. From 9 it will become 8. Okay, S is already incremented, so S again from 1 to 0. Then again it will increment the second slot of buffer. Then signal S again becomes from 0 to 1, and this F becomes 1 1 plus 1 equal to 2. So the value of F will be 2. Now here if we can see, if it enters the consumer section, so what will happen? Wait, this particular function will return what? Wait F. What is the value of F? F value was 2. So it will be decremented. So 2 minus 1 becomes 1. And what was the value of S? 1. So it becomes 0. So it will enter the critical section. It can take that particular, it can read that particular value from the buffer, and it will consume that. And what is this now? The 0 becomes 1, and E will become, what is the value of E? Be E will be incremented. Okay, E will be 8 plus 1 will be equal to 9. Okay, and this is how it will work. So at a particular time, if you see, the mixture exclusion is there. Whenever the producer is there in the critical section, consumer cannot enter the critical section, and whenever consumer is in the critical section, here producer cannot enter the critical section. Okay, so if the size of the buffer is only 1, okay, there is only one slot, so at a time producer can fill up that slot, and the next time consumer will consume that slot. So there can be multiple producers and one consumer, or there can be so both all the producer processes can work simultaneously. Okay, but consumer and producer cannot work simultaneously. Okay, now we'll check for overflow and underflow. In underflow, at the beginning, okay, in the initial condition, what is the value of f? F is equal to 0. And if the consumer starts executing, what will happen? Can it go into wait? Because see, wait, what is the value of f? F is 0. So if you remember the syntax of the code of wait, what we have written here was like this. It checks while the value of f less than equal to 0, else f will be equal to f plus f minus 1. Okay, sorry, f minus 1. So when the value of f is 0, what will happen? It will be in this loop. It cannot go to the next statement. So at the beginning, if the consumer process tries to execute, what will happen? It won't allow the consumer process to go into critical section. Okay, similar. So this is how it works for underflow, and for overflow. Suppose after this, the value of E is suppose 0. Okay, at the end when all are filled, all the buffers segments are filled, the value of E will be 0, right? The value of E will be 0 at the end. Okay, so that time what will happen? So this wait will be the wait. What will happen to wait? Wait will not allow the producer process to go into the critical section. So by default, this entire structure is taking care of underflow and overflow.